Okay, so we did finish one, what do you call it, factoring technique. What I'm gonna do now is I'm gonna start another one. Now this one can be a little involved. It's not terrible once you get the hang of it, but it might take some practice. What I did email everyone was a worksheet as well. So, I mean, I expect that we'll get to that, but I'm not 100% sure. But anyway, the new technique we have is called factor by grouping. Okay. And again, if you can't see the slides or you can't hear me, please just make sure to speak up because I can't see the chat. So, I mean, now I can. But anyway, this new technique is called factor by grouping. I did write out a procedure here. And it's what you use when you have 4 terms. I mean, I will demonstrate this, of course, using examples. Basically, what you do is you factor out the GCF from the entire polynomial first. Then what you have to do is you want to make 2 groups of 2 terms each using parentheses. And you really want to make sure, you'll see when we're doing examples, that addition is between the second and third term. You may have to change subtraction to adding the negative. I mean, that's really optional, but I just think it's easier to do it that way. But I will demonstrate through examples today. And then each of those 2 groups you're going to factor individually. Mostly just by taking the GCF out of each group individually. And what's left over in parentheses, you want that to be the same in both groups. If it's not, you have to go back and try again. But if it is, you factor that out. I know it's really confusing, this process. When I first saw it, I was like, what on earth, is the teacher saying? But again, we'll do some examples. So again, it's in the notes, so I did email this to everyone. But let's say we want to factor this. There are 4 terms here. And if there's 4 terms, you really want to try factor by grouping. Okay, so first, let's get the GCF out of the entire polynomial. All right. Now, so here, we see there's a non-zero constant, okay? There's a non-zero constant. Well, that tells you that m has to be 0. In other words, you can't factor out x at all. The x cannot be in the GCF because not every term has a variable in it. Also, there's a coefficient of 1. And if there's a coefficient of 1, that means the greatest common factor among all the coefficients and the constant term is going to be 1. So basically, we're going to get, let me see if I can write it out, actually. This might be easier. Right? Remember how the GCF is of this form? B x to the m. Basically, we have the smallest exponent of x is 0 because there's a non-zero constant term. And because one of the coefficients is 1, right, the leading coefficient here, what we get is b has to be 1. Mostly because the only factor of 1 is 1 itself. So the only common factor among the coefficients and the constant term is 1. Okay, so the GCF is 1, so we really don't factor that out. If you look at the next line, notice what I'm doing here. I'm forming 2 groups of 2. And there's addition between the second and third term. That's good. Also, you want to look at the second and the fourth term. If they're opposite in sign, you will have to factor out a negative from the second group. I think I might have skipped that in the beginning. I do apologize. Let me see. Oh, it is here, though. It's in step 3. If the second and fourth terms in the polynomial have different signs, one's positive, one's negative, you have to factor out a negative. Might be just -1 from the second group. You'll see why in some examples we do. But we do 2 groups of 2, okay? And now we want to factor each of these 2 groups individually. So again, this is the polynomial we began with, right? Let's factor out the GCF. We got the GCF to be 1, so really we don't factor out anything. Now we have 2 groups of 2, as you can see. Now each group we're going to factor individually. Looking at this here, right, we see that the smallest exponent of x is 2. So again, going to that b times x to the m here for the GCF, our m is 2. Just like up here, we get b is 1 because a coefficient is 1. Here, the leading coefficient. So the GCF of this thing has to be x squared. So we factor it. So we're going to factor that out. Now remember, how do you factor it out? Well, you have to put it in front and divide. Put it in front, and then you divide. Right? And when you divide into each term, as you can see. And when you do that, x cubed over x squared, that's actually the same as subtracting exponents, and you get x to the 1. Here, 5x squared over x squared, right? The x squares cancel, you get 5. So from the first group here, right, we made the 2 groups. From the first group, the GCF of it alone is x squared. We factor it out. We're going to do the same thing on this one. Namely, we're going to factor out the we're going to find the GCF of this group alone and factor it out. All I did here, right, the first group, after factoring, we got this. I just replaced that in the polynomial. That's all I did. Okay, so let me say it again. Right, after we found the GCF of the first group and we factored it out, as you can see, I just replaced that here. That's all. For the second group, right, we'll notice that, well, if we look at the coefficients and the constant term, 3x and 15, well, okay, so what are the factors of them? I mean, notice right away, the smallest exponent of x is 0. Right? You can't factor out x. There's a constant term here, a non-zero one. So for the coefficients, for the numbers, the factors of 3 are 1 and 3. What are the factors of 15? 1, 3, 5, and 15. So the greatest common factor of the coefficients and the constant term, it's going to be 3, as you can see. I mean, really, since 3 is a factor of 15, that should tell you right away that 3 had to be the greatest common factor of the constant term and the coefficients. So that tells us B has to be 3. Also, again, since there's a non-zero constant term, the smallest exponent of x is 0, so m is 0. The GCF then for this is 3. So again, we're handling the second group here. We found its GCF to be 3. Let's factor it out. And we're factoring out 3, right? We put it in front, we divide. Then, right, we divide into each term. And when you divide, the 3's here cancel, you get x. 15 over 3 is 5. Again, if I go too fast, don't be afraid to say something, okay? I know this is not easy, believe me, I know. It's a little intimidating. So I understand that. So for the second group, we got it to be equal to 3 times x minus 5. If we put that in here, right, notice that the two groups here have something in common. What's in parentheses? This is what I meant. Let me go back to that. Well, I guess, sorry. On the first slide, one of the steps say that if what's in parentheses is the same thing, then that's good. That's what you want. I mean, I don't know if those are the exact words it says, but it's along those lines, right? So after we factored each group, in parentheses, we got the same thing. And what do? We factor it out. And that's what I'm doing here. That common thing in parentheses, the common, x minus 5, we take it out, we divide, as you can see. And how do we divide? We go into each term. Let me actually show the markings. That might make it a little bit easier. When you divide, these cancel. Oh boy, that's all right. These cancel too. So we're left with x minus 5 times x squared plus 3. And that's what we end up with. Okay, so again, the polynomial we started with was this. Right, the GCF we found of the whole polynomial is 1. So we really don't factor that out. We form two groups. Again, I recommend having addition between the second and third term, because when you use parentheses, having addition makes the computation a little easier and helps prevent mistakes. At least with me, it does. Each individual group, we find the GCF and we factor it out. What's in parentheses here from both groups is the same thing. We have the same thing in parentheses among both groups. Then we factor that out. And finally, we get our factorization. No, I'm not done yet. I just want to